We've all heard about Mars colonization, and presently there is a lot of interest in this idea. Why? To preserve the human species. However, the idea of colonizing Mars is a far-fetched one because many space agencies like NASA, Russia's Roscosmos, and other private space companies don't have the technology that is capable of launching humans to the Red Planet. However, what if we successfully colonize Mars? Well, here's what would happen. Mars exploration has been ongoing since Galileo Galilei first discovered it back in 1610. If you want to know more about the history of Mars exploration, you can find that episode on this channel. However, before we set a plan for colonizing the Red Planet, we will need to get there. So, how do we get to Mars? We'll need a spacecraft that is fast enough to escape the pull of Earth's gravity and powerful enough to be able to lift off. The biggest challenge will be to accommodate the mass of the payload, which includes the spaceship, the crew, fuel, supplies, and other items needed to complete this mission. The mass of the payload typically makes up a very minor portion of the launch vehicle's overall mass. For instance, the 3,000-ton Saturn V rocket that carried Apollo 11 to the moon could only launch 50 tons, which is less than 2% of its initial launch mass. Another main problem would be fuel efficiency. According to scientists, we can't use regular fuel as it will tend to burn out faster, making for low probability of lifting off. As a result, we would have to use plasma, which is a highly hot gas, as fuel. Plasma and electromagnetic forces can be used to accelerate a spaceship fast and effectively with an engine called an ion thruster. So, if there was less fuel required to make the trip, then the crew would have more room to pack supplies like food, water, air, and other equipment that future human colonies on Mars would need. Astronauts will be able to transport the same amount of cargo between Earth and Mars in just one trip, thanks to the fuel efficiency of plasma propulsion, which will save them from having to make 10 trips. Because there will be fewer trips, this will also be much more cost-effective. So far, only uncrewed spacecrafts have made the trip to the Red Planet, but that could soon change. NASA is hoping to land the first humans on Mars by the 2030s, and several new missions will be launched before then to push exploration forward. But say we do end up making one of these spacecraft with ion thruster engines and we're ready to launch humans to the Red Planet. The second step would be to make sure we launch at the right time. We first need to understand mass in the Earth's orbit around the Sun, and in order to determine when would be the best time to launch the rocket. The space and distance at which Mars and Earth orbit the Sun are different. Sometimes they are very far apart, and other times they get closer. So when do the two planets align? Well, that's about every 2 years. The distance between the two would be much closer, hence needing less fuel. The theoretical point at which Earth and Mars would be closest to one another would be when Mars is the perihelion or closest to the Sun and Earth is the aphelion or farthest from the Sun. In this case, the planets would only be separated by 33.9 million miles. But, and this is the problem, this has never actually occurred. The two planets made their closest known encounter in 2003 when they were just 56 million kilometers away. Mars and Earth are separated by 140 million kilometers on average. So now that we know the conditions, say the spacecraft finally makes it into space. But here's the tricky part: propelling the spacecraft in the right direction. In order to do this, we've got to make sure our aim is just right. You can't aim for Mars when you're already set to launch. You have to aim for the destination after first launching into space. It's almost like passing the football to the quarterback before he makes the final pass. Also, another fact is that to make sure you don't miss Mars, you might also need to make a few thrusts to adjust course along the way. If everything goes as planned, it should take 7 to 8 months to reach the Red Planet. A one-way trip to Mars could take up to 9 months, according to NASA. Overall, if you wanted to make a round trip, it would take about 21 months because you would need to wait 3 months on Mars to ensure that Earth and Mars were in an appropriate location for the return journey. The colonization of Mars. Alright, we have reached the planet, but we can't just land immediately. First, we've got to orbit the planet just as the International Space Station orbits the Earth before landing. Through the entry capsule, which is part of the spacecraft, we can make our way down to Mars' surface. At this time, the capsule will experience aerodynamic drag as it travels through Mars' atmosphere. If you want to understand this, you can just stick your hand out of a moving car's window. The force and feelings are similar, but obviously not as strong. But once you're through the entry capsule, the retro rockets will slow down and you will be able to land gently and safely on the Martian surface. How much time would all of this take? Well, it would take less than 10 minutes. The colonists will need to live in a sealed, climate-controlled habitat after they reach Mars' inhospitable surface. Mars is a very cold surface. temperature of -81 degrees Fahrenheit, and a thin atmosphere primarily composed of carbon dioxide. Additionally, Mars lacks a powerful magnetic field as Earth does. Its surface radiation levels will also be higher. This radiation is made up of energy from the sun and other cosmic rays. The levels on Mars are above the dose for astronauts that is advised for lifelong exposure. Therefore, a technological fix is required to protect future Mars expeditions. But since this is a hypothetical scenario where we can successfully colonize Mars, here's what we would need to do. When we land on the planet, we'll notice that it's missing something. That thing is oxygen. Let's not forget it would be impossible to breathe on Mars considering the planet's atmosphere is at least 95% carbon dioxide. But luckily for us, scientists have made several proposals on how to convert carbon dioxide to breathable oxygen. Apart from breathing, we would also need enough oxygen to produce rocket fuel so that people can at some point return back home to our planet. And it requires a lot of liquid oxygen to launch a rocket. The second thing that would be missing is water. Mars doesn't have water like our planet, so the first people to reach there would have to bring a certain amount of water with them to Mars. If we wanted to colonize the planet, though, we would need to find ways to produce as much clean water as we could for future settlers. So what can we do? Well, we can use autonomous mining techniques, which employ robotic technology to mine the ground and retrieve water from the layers of ice or from rocks that formerly made up Mars's ocean. The third thing that would be missing is gravity. If you look at astronauts residing in the International Space Station, you will find that they experience a lot of physical issues. Some of them come back home with bone and muscle mass loss, while others experience a change in their DNA. Mars has about 62% less gravity than our planet, so if you are planning to stay on Mars for a long time, you will definitely experience a lot of health issues. However, scientists have proposed ways to create artificial gravity both on the planet, but these are all very preliminary suggestions and nothing concrete has been attempted in space. But let's say we have finally managed to create this. Well, the fourth issue is with radiation. When on Mars, we need to worry about two types of radiation. One is solar radiation, and the second is galactic cosmic radiation, which is radiation caused by the remains of a supernova. Earth's atmosphere protects us from these, but Mars's atmosphere is much weaker. Pinning down exactly what we need to protect the colonists from this increased radiation will be tricky, and scientists are still debating on how to solve the problem because with increased radiation, there will be an increased chance of cancer, neurological degeneration, and even death. Lithium metal hydride could be utilized as a shielding substance during the journey to Mars to lower radiation levels to those experienced by astronauts on the ISS. Once on the planet, people would have to dwell in low elevation, heavily insulated towns or seek refuge in lava tunnels below ground. But let's not forget that there are a few more issues to deal with. One of them would be the temperature. The average temperature on Mars is -80 degrees Fahrenheit, which is extremely cold. According to some extremely forward-thinking scientists, we could terraform the Earth and effectively produce a greenhouse effect to warm the climate. To make the environment habitable for people in the near future, however, the previously mentioned domes or lava tubes they reside in would need to be temperature controlled. The second would be energy. The good news is that Mars rarely has clouds and never experiences rain. This means that solar panels may be positioned practically anywhere that people live and would continuously provide energy, except for when the red planet is covered in powerful dust storms that can last for weeks. The third would be the soil. Perchlorates or CiO4 are harmful to humans and present in Martian soil. Any attempt to cultivate food on Mars would require the removal of perchlorates from the soil, and even then it seems like that only specific plants could grow there. Looking at the entirety of the scenario from a realistic point of view, it will likely be a long time before we are ready to successfully colonize the planet. Though we are not ready yet, hopefully we soon will be, with the help of private and public enterprises such as SpaceX and NASA. So let us know your thoughts in the comments section below. Subscribe to our channel for more content like this. Press that bell icon to never miss an upcoming update, and thank you for watching.